Okay, so I already entered in bearing, sludge, and skidding, and you can see that there are 9 results that pertain to this. So we have bearing wear, bearing failure, overheating, lubrication contamination, lubrication starvation, wrong lubrication viscosity, excessive greasing, chemical attack, or incorrect bearing selection. Each one of these are really important, but we're going to look at bearing failure. And so you can see that there's 5 senses you can pick from. So visually, what does it look like? Is the lubrication burnt, blackened, or carbonized grease, dry or empty raceway tracks? Heat tinting. Heat tinting is like a bluish, purplish color formation. It almost looks shiny, like you'd see when grease is poured on concrete. Metal smearing, block lube fittings, disconnected auto lube lines, or complete empty oil reserve. So let's go ahead and pick that one. And then these are the kind of root causes that can be caused from that. So severe lubrication starvation, loss of grease or oil supply. So why is that? Severe lubrication starvation. First, it's going to get gritty in there because you're going to have some old grease in there. And then if it's in a dirty environment, you can get contaminants packed into that. And since it's not being cleaned or PM'd adequately or even at all, it is going to fail. And then you're going to see the darkened, carbonized sludge on the bearing outside outer rim. Okay, and you're going to start to see it slide. And you're going to, in this case, you could hear hissing, because it's going to be metal to metal contact. Now, a gross misalignment, shaft housing, coupling. So this is if the bearing is dying the way it is because of a gross misalignment. Misalignment, what it will do is it's going to have metal to metal contact in areas that you're not going to be able to predict, and it's going to act like sandpaper. So it's getting those particulates into that raceway and into that lubrication system. Your lubrication system becomes dirty and contaminated, and it becomes very difficult to keep it clean. Any lubrication, again, in that area, because you've introduced this metal-to-metal contact, that's where your contamination comes from, and then it becomes cross-contamination to the lubrication system. The lubrication system becomes dirty, and then you're fighting that. So that's how gross misalignment can cause that. Heavy contamination is similar to gross misalignment in that there is a contaminant in the raceway and where the balls or the pins or the rollers have to be clean and make good metal to metal contact. But what's happening is that your environment that you're in is actually causing contaminants to enter into that raceway and clog it up. So you're going to see this in heavy industrial manufacturing, whether it's metal parts, CNC. And what I mean by that is your metal ingress, your die casting, things like that. You're going to see that in flour environments, high sugar content, things like that, food production, even in pharmaceuticals, although pharmaceuticals, unless the bearing is inside to that, it's very, very rare as opposed to, and semiconductors, you wouldn't see that really. Severe overloading, shock loads, process upsets, and hammering. Severe overloading, that means you're getting metal to metal contact because the bearing is not able to support that load. And so it's getting crushed. And then you're getting that metal to metal contact again. And then you're having the abrasives from the contaminants. Cage failure. Now that is cage failure. You're going to get metal to metal contact. Then you're going to get a crunch sound, go like that. And what will happen is, of course, you're dead in the water. And your cage just completely died. Catastrophic lubrication failure, wrong lubricant. If you're using the wrong lubricant, but you're doing everything else correctly, you're still going to get a failure because that lubrication is not capable of sustaining that environment, perhaps the temperature or the usage or the churns are more aggressive than what is expected. You're going to have issues. Incorrect mounting fits. Chronic overheating. Overheating is huge, but overheating is, again, it's more of of a tertiary problem that if you think about compounding interest, it's going to have multiple variables that led to it prior to it overheating. So let's go ahead and let's look at severe lubrication starvation. And here we have, what is it? And this is a video that will go over the entire component failure so you really understand what is going on. The operator can watch this at their station and understand right away during AM, PM, TPM events or in the classroom environment. You get a defect video specific to what's going on. So you can see the sludge in here. You can see that the bearings are covered. The outer and the inner raceway are covered. And then a defect image is a close-up. And then you can see what causes that. So you have your different root causes, as well as the severity, occurrence, and detection with an RPN, a risk priority number, and then whether it's the criticality is high. You have your no-go thresholds, and then you have whether it's a leaking, flaking, metal debris, pit holes. This is what you're going to see when you have those issues. Now let's go back. So what is it? It's going to tell you exactly what the problem is, so we can learn in detail what it is. Bearing failure refers to the malfunction or breakdown of a bearing, which is a crucial component in machinery that allows for smooth rotation or movement of parts. This failure occurs due to various reasons, such as excessive wear, inadequate lubrication, contamination, misalignment, or overload. And those can all be interconnected. They can all be related. If you have more than one factor, then you're going to want to look at all of them and address them. And then, so what is the operator going to see as this issue starts to evolve? And you're going to say, and what I was talking about with the 5 senses, you can get a temperature gun for a lot of times under $5 over at Walmart, and teach your operator how to take a temperature reading and record it on a particular part of the equipment. You would make a mark on, let's say, a motor where you want the reading taken and what time and what intervals, and the operator can then record it. So the issue is if it's running 10 to 20 degrees higher, Celsius higher than baseline, initially as lubrication film collapses, temperature spikes rapidly in severe starvation due to metal-to-metal contact, as we had talked about earlier. Escalation here is, which is the escalation. When should I escalate? The problem is when it reaches 20 degrees above Celsius. Now, what you can do is at the motor, your CI person or your maintenance or technician can put the temperature range at which that, let's say it's a motor or a bearing even, is supposed to be at. What temperature should this bearing be? And since we're talking about bearings, let's go ahead and use bearings. What temperature range is this bearing? What is normal? Okay, so you put a specification there, and then you can say, watch out if temperature exceeds da 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 da. Or you can put it in their CILs to look to make an inspection during the run, because you're not going to put your hands in the way. You're not going to touch the bearing. You just take the temperature gun, aim it at the little mark that you have applied, and then take your reading and write it down. Once that is exceeded 20 to 35 Celsius, then they're going to get in touch with maintenance. Now, smell. It's burnt oil smell, an acrid oxidized grease odor, a sharp metallic scent from tearing surfaces, and strong rubber oil from overheating seals. So it's really going to smell really bad. So they're gonna smell it right away, and they're going to escalate once they detect that smell. And then they're going to have a sound, a dry running bearing produce. That's that metal to metal contact that causes a high frequency screech or grinding, a harsh squeal at startup, deep rumbling as the surfaces degrade, and extreme ultrasonic friction. Now, they don't need to know about the ultrasound. What they need to know is, do I hear a metal to metal screeching or grinding or a harsh squeal when I start up? What does it sound like when it runs? Visual, they're going to look for that sludge, so that burnt, blackened, or carbonized grease. They're going to, once they see that, you're going to know right away if your bearing is failing. So that is crucial for them to understand. I mean, you can teach just about anybody to understand what sludge looks like and what does that mean. When do I escalate? If I hear a different sound, when do I escalate? Now, in manufacturing, sometimes the equipment runs really loud, so you may not hear that, but you might also see vibration. So you see rotation feels extremely rough, gritty, or binding due to fused metal debris. So, you can see that the operator would be out there during their CILs, during the run. They have visuals. You have selected the critical points for them to inspect. You have established the intervals in their CILs or their startups or during their run information. And you can either log it on manually or you can put it in a computer system. And very easy to put that in Excel and put it on the floor. Very, very easy. If you have a terminal, you can put it in Excel. If you have other computer programs, you can also log it that way. It's very simple to add that kind of functionality on the floor these days. Diagnostic fingerprints, broadband vibration escalation with dominant HF accelerations as rolling surfaces degrade. Now, what does that mean? That means that when I am looking at my vibration analysis, if I start to see huge spikes during the run, I know there's a problem with my bearing. And your engineer will look at these ones, these diagnostic fingerprints. So what's the failure sequence? Progress. That's dead on, right? Contamination. So what do I look at? I'm going to look to see is there a lubrication schedule. Once I see sludge, where is the culprit? I'm going to start up in a root cause analysis, and I'm going to start to look at what is going on here. Stop it. So if it's misalignment, I can look at the pedestal and see if there's any misalignment to that particular area. You can, if for a bearing that's misaligned, you're going to see a wobble, and you will see the bearing actually wobble, just like a walk the dog, right? And then inadequate lubrication, the operator is going to know if it's lubricated or not. And then the contamination, the operator is also going to know whether it's a contaminated environment. You just got to tell them how bad, right? And then increased friction leading to elevated temperatures and vibration. Visible damage such as pitting, spalling, or cage failure, sudden bearing seizure or breakdown, and collateral damage to adjacent components and system failure. Bearings make up 40 to 60% of all manufacturing failures. Root cause analysis, which is what we're doing here, can eradicate 85% of that. And we can teach the operator how to detect failure progression stage 3 or 4. Once they start to see visible signs, they know it's time to react. Collateral impact, you're going to have contamination of lubrication system with metallic debris. Just as we talked about, as the lubrication flushes the bearing, you're going to get those metal-to-metal debris that was caught up from their contact, and it's going to contaminate the lubrication system. Accelerated wear of nearby gears, shafts, and seals. Yeah, when it gets the lubrication contaminated in that environment, you're going to get a lot of vibration from the particulates, and you're going to also get that into your gear shafts and seals. You just are. I mean, it's a total degradation failure. Increased maintenance costs and downtime. Now, this is the true kicker, and this is why I'm telling you it now, so that other people can see this and they can be the hero, right? I don't care who's the hero. I want to get this out so that equipment and manufacturing in America can be quite strong. If you're watching this from another country, then I also bless your country as well. I want all of us to succeed. And so what are we looking at? We're looking at what are the systems that cause failure. We're teaching our operator temperature, vibration, misalignment, and all those different types of cues, such as sludge, and what to do when they see it. So the failure mechanism is an abrasive wear, the surface damage caused by the hard particles or debris grinding between moving parts. It is that abrasive wear from the metal to metal contact within the bearing and its components that is causing the abrasive particulates in that environment. You'll have surface fatigue, so micro cracks and spalling due to repeated stress cycles. Adhesive wear, material transfer between contacting high friction. Corrosive wear, material degradation due to chemical within the contaminants or moisture. You're going to have fretting wear, and then you're going to have erosive wear. So what are the corrective actions? What should we do immediately? What can my operator do as they're starting to see these issues? They can immediately shut down an inspection of affected equipment if it gets to the escalation point in your matrix. And you're going to want to have a matrix, and you're going to want to teach the team that matrix. So you're going to have step one, you're going to log out and tag out the machine. You're going to remove the bearing or tear down analysis. You're going to inspect the shaft and housing for secondary damage, and you're going to go clean lubrication system thoroughly. That's what your technician or your maintenance mechanic does. They really want to make sure they're going to get this, and then they're going to replace bearing with correct type and clearance. So what you want to do is ensure what factors cause that. We'll launch the root cause analysis or the breakdown analysis, whichever one that your company does. Preferably they do both, and in that case you would do the BDA. And then you're going to look at, is the speed, is the load, is correct? And once you are certain of what those are, and they might be multiple factors first, then once it's a good conditioned system and everything has been removed that is causing issues, then you replace the part. Otherwise, you're going to have premature failure. And in this case, it's going to come quicker than the first failure. So then you thoroughly clean and flush your lubrication system. You refill with the proper lubricant. You investigate and correct causes. You follow the root causes to completion and make sure that the environment is pristine. Unless you are running production that is critical and it cannot, then you replace the part temporarily until you and then you replace it. Now, if you catch it, and you should, if your operators and your technicians and your maintenance and your escalation plan are all in place, understand what to do when they detect early symptoms of failure, you won't have an unplanned downtime. You'll have a planned downtime, and you'll eradicate these issues. Then you're going to look at how did the operator can be of a service to ensure that the next one doesn't go down, or in this same thing, the same techniques and methods that you have put in place would be applied to all places that are similar in condition and similar part. You'll have technicians, what they will do, and then you also have your engineer. Number one thing of all of this is just teaching the operator basic 5 sense diagnostics. It really is. It is better than conditional monitoring, because conditional monitoring can be very expensive. You have to have your maintenance team trained. And even then, if you are low on maintenance, your operator has their hands on that machine the whole time they're working, right? It's their machine. That's what TPM is all about. It's about the operator owning their equipment, becoming equipment owners. And in this case, they would be trained in the 5 senses, especially around bearings, because bearings, again, is 40 to 60% of all failures in manufacturing. Can you imagine what that would do to your OEE if you're very low? These simple fixes that don't cost a lot, that $5 temperature gun, it will have a huge impact on your overall OEE. And you will start to have a smarter workforce. Now, the question is, okay, well, if they're expected to do more, then they're going to want more money. Not necessarily. They want to have these skills because they're not going to have to constantly have to fight a machine, right? And of 30 years of working as a consultant in different industries, I have never found where an operator said it's not my job. 30 years I've been doing this day in and day out. They all want to know how to make sure that their machine runs smoothly. Okay. And then the next thing that's really important, operators understand. Here you use language cage deformation at pockets. You would hear a click or a knock when the machine starts or changes direction. So this would say, what is cage deformation? Well, your operators know what to look for when that happens. It says balls are moving within a loose or damaged cage, resembling marbles clattering tray. This allows them to relate what that bearing is undergoing and what it sounds like in layman terms. Of different inspection layouts so they can see the inspection. Now, the next important thing is most engineers, especially in a very high end, they're going to want to do their 8M. So this goes through what are the triggers. You see the impact. You can see the severity of this bearing failing and what it does. You can see the risk factors or the no-go factors, diagnostic test methods. What does it mean? And then how much does it cost? Because everybody wants to know how much it costs. Now, for people who want to learn more in depth, the failure progression, it will tell you that a stage 0 failure progression is pristine state. There is no failure. As you get, you're going to see initial surface wear that is going to be microscopic. In stage 2, you'll see that the wear becomes more evident. And in stage 3, you're going to start to see detectable issues on the component. You're going to start to see the progressive surface damage. You're going to be able to see that physically. Your operators will be able to see damage at this stage. At stage 4, they're really going to be able to see it. And at stage 4, if it's not caught here, it goes to stage 5, which is complete failure. A complete failure of a typically 5 to 10 times the part cost, and the part cost is between 500 to 15,000. So it can be quite expensive just for one unplanned downtime. And you go through operator tasks more in detail. What is the no-go state, maintenance task, as well as engineering task. And then we have a gallery so they can really understand what is the bearing failure, what is the fingerprint, noise, and particulates in your lubrication. You can see all that physically. And then we go to prevention. So you can have a sampling plan, and we do have a troubleshooting guide that walks through how to troubleshoot for failures. This one is how to make a defect card, how to use your 5 senses for detection, and your plan correction, your escalation triggers, your no-go thresholds, your out-of-control action plan, and then you can get support or submit a defect card from the database. You had your FMICA analysis and your prevention. Here is your troubleshooting. So what are the fingerprints? Again, what are the fingerprints? What am I looking at? How do I troubleshoot it? Actions. What are the immediate actions? What's prevention? What's the best known practices? And then long-term actions. So this is really great if you are going to need continuous improvement savings for the following year or currently, and you can see how much upgrading, for example, upgrading sealing technology steps, right? And it's an annual estimated savings of $20,000 annual per asset. And you can see all the different kinds of things that you can do to prevent this failure from happening ever again throughout your entire system. Yeah, so this is what I wanted to share with you. And I think that it will really help your company improve their OEE. And that's what it was made for. Thank you for listening.